So there's our polynomial function, 2x cubed minus 9x squared plus 10x minus 24. We know that x minus 4 is a factor. I want you to find me the zeros of the function. How many are we supposed to get, or how many do you need to get? 3 of them. Okay, so find me all 3. So we know that if x minus 4 here is a factor, then we can set our factors equal to 0, and we can solve that. And so x equals 4 is a 0, a root, an answer, right? Okay, which we also need going forward, because now we can say that if 4 is my 0, my root, my answer, okay, my x-intercept, then my coefficients would be 2, negative 9, positive 10, and negative 24. So I drop it like it's hot, and I get 2, multiply, I get 8, add them together, I get negative 1, multiply them together, I get negative 4, add them together, I get 6, multiply them together, I get 24, add them together, and I need to get 0 down there, because if I don't get 0 at the end, then x minus 4 is not a factor, and someone lied to us. Okay? But so we got the 0, so that's true. So now we can say that f of x, our function, this thing right here, that can be rewritten as, my first factor was x minus 4. My next factor is going to be 2x squared minus x plus 6. Okay? Did you ever find a pair that it factors to? No. No? Okay. So did anybody find a pair that purple factors to be? No, I couldn't find one either. So if we can't find one, Brennan, what do we got to use? We got to use the quadratic formula then. Okay? Because now we can say that x minus 4 equals 0. So x equals 4. That's the one we already found. We can also say that 2x squared minus x plus 6 equals 0. And so our quadratic formula says x is going to equal the opposite of b. Well, that's going to be positive 1. Plus or minus, big square root, negative 1 squared minus 4 times a times c all over 2 times a.
Come on. I didn't use like the quadratic formula. I used like another thing.
There was nothing else that you can use here other than the quadratic formula.
Sure, because
I'm positive.
I did. It kind of worked.
It doesn't. Promise. I'll even pinky swear on it.
All right. You can also look here.
I know, but it's not right. I can tell you that right now. Unless you got 1 plus and minus I times the square root of 47 all over 4.
How do you know you're not wrong?
Because I know I'm right. Yeah.
Well, I know I'm right.
Yeah. Did you get the same answer?
No.
Okay. So do me a favor. Plug yours back in. Okay. Plug one of your answers, not 4, because 4 is going to work. Plug one of your answers back into the function, the original function, and if you get 0, you're right and I'm wrong.
All right.
There are times when I am wrong. Okay? Good? So today, what's going to happen? So last week, we gave you problems that it looked exactly like this. Okay? Right? Where we gave you this ugly looking function, polynomial equation, expression, function, whatever you want to call it. Okay? And we said, here's a 0, here's a factor. Find me, blah, 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 blah. Okay? Starting today, we're taking that extra part away. And we're just going to say, here is this highlighted function, solve it. Without giving you this extra, here's one of the things that makes it work. You got to find them all to make it work. And in order to do that, we're going to be using something called the rational zero theorem. Okay? Now, the rational zero theorem says that for any function that you can come up with, doesn't matter what it is, okay? Every rational zero, now we should actually probably take a pause. Does everybody remember what it means to be a rational number or a rational zero? Rational numbers out there? We've got rational and irrational numbers. Does everybody remember what a rational number is?
A number that makes sense.
It is a number that any number you can think of is a rational number, with the exception of pi, e, and a square root that doesn't come out, because those are irrational. A rational number is a number that can be written as a fraction. Okay, so any number that can be written as a fraction. So any of the zeros, the rational zeros of that function, come from in the following form. So they take, it's got to be a factor of the constant, okay? A factor of the constant, that's the last number that comes out, divided by a factor of the leading coefficient. Okay? So any rational zero is going to be of that form for any function. It's going to be a factor of the constant divided by a factor of the leading coefficient. You guys are probably going to write that down, because that's how we're doing everything this week. Okay? This whole thing. Yep, write all this down. This is how you do this stuff. In class, we take notes, so that when we're at home tonight and we're like, oh, I don't know how to do this problem, oh my God, I got notes to look back on. Okay? So, again, doesn't matter what the function looks like. Okay? The only two numbers that matter are, if it's written in standard form, are the very first number and the very last number. Okay? So the first thing that you have to do is you have to list all of the factors of that constant number. So what are the factors of 15? What numbers evenly divide into 15? 1 and 15. 3 and 5. Any more? Okay? There should be 4 more. All the negatives, right? Okay? So plus and minus 1, plus and minus 3, 5, and 15. Right? Okay? Then I need to find all the factors of 2. One and 2, right? Yep. And they're all pluses and minuses. Okay? So it says we got to take a red number and we got to divide it by a green number. Right? So if I take all the red numbers and I divide them by the first one, I get that, right? So that's me dividing them all by 1. 1 divided by 1 is 1. 3 divided by 1 is 3. 5 divided by 1 is 5. 15 divided by 1 is 15. Okay? Then I got to take all those red numbers and I got to divide them by the next green number. 1 divided by 2 is 1/2. 3 divided by 2 is 3/2. 5 divided by 2 is 5/2. 15 divided by 2 is 15/2. And that list is all of the possible, all of them aren't, but that's all of the possible rational zeros for that function. Okay? From that list that you generate, what we've done is we've taken an infinite amount of possible zeros, and now we've shrunk it down to 16. And from that 16, we can find how many for this function? 2. We can find the 2 out. You find me the list of all the possible zeros for this function. Not all the zeros. I'm not looking for 3 zeros here. I'm looking for the list of all of the possible ones. So factors of 8. What do we got for factors of 8? 1, 2, 4, and 8. And then all the positives and the negatives, right? Okay. What do we got for factors of 2? 1 and 2. Okay. So take them all the reds, divide it by 1. So that would be plus and minus 1, plus and minus 2, 4, and 8. Yes?
Yes.
Okay, now I gotta take them all and I gotta divide them by 2. Okay? So 1 divided by 2 is 1/2, right? 2 divided by 2. 1. Already got it. Definitely don't need to rewrite it down again. 4 divided by 2. 2. Got it already. 8 divided by 2. 4. Got it already. Don't have to repeat those values. Okay? So there are the 10 possible zeros that we can get. Okay? All right? Let's do this. So here now is our function. Okay? Start by writing down the function. F of x. If you're at the bottom of a page, yeah, I'd start at the top of a new one. Okay? F of x equals x cubed plus 2x squared minus 9x minus 18. X cubed plus 2x squared minus 9x minus 18. Okay? Now, I'm a big, do these kind of steps, every single time kind of guy. Okay? So the first step that you are going to do after you wrote down the function is you need to find all of the potential zeros. That's like the example that we just did. Okay? So you need to find me the list of factors. So what are factors of 18? 1 and 18, 2 and 9, 3 and 6, just those 6, right? Okay. What are the factors of 1? Trick question. It's just 1, right? Okay. So my list of potential zeros is that. Okay. Which could be a question on Friday's quiz. Okay? We could stop right there and say, just find me the potential zeros. Okay? Okay, so that's one possible answer or possible question. Okay. Step 2 now says that you need to, from this list now, you need to find a 0. Okay? So, how do we do that?
We take like one of the numbers and replace the x with that number. What you use to like I used to check my answer.
Okay. Or that before. Or what else could we do? We can do synthetic division. Yep. Yep, we can do synthetic division. So we've got 2, 4, 6, 8, 10, 12 possibilities. Pick a number. Any number. 2?
6.
Okay. So I've heard 2 first. So I'm going to do 2 into 1, 2, -9, -18. If 2 is a 0, what should I get down here?
0.
I should get 0 right there. If I don't, 2 is not a 0 and I got to keep going. With me? Okay? All right, here we go. 1, 2, 4, 8, -1, -2, I get -20 there. Is 2 a 0? No, it's not a 0. So positive 2 has been crossed off our list. Not a 0. Okay, so I need another one.
6.
6. 1, 2, -9, -18. 1, 6, 8, 48, 39. A really big number. Let's go with 234. 216. 0. Not a 0, right? Okay, give me another number. 3. I like 3. Good choice. 1, 2, -9, -18. 1, 3, 5, 15, 6. Uh-oh. Uh-oh. What did we find? 3 is a 0. Okay? So 3 is a 0, which means that what is the factor? X minus 3 is the factor. Okay? Because our next step is going to be, we are going to want to factor the new polynomial. Now our new polynomial that we have is f of x equals x minus 3 was our first factor that we found. What's left over is right here. X squared plus 5x plus 6. Can x squared plus 5x plus 6 be factored to what? X plus 6 and x minus 1. No. 2 and 3, both positive? Yep, because I need two numbers that multiply together to be positive 6. Positive 6 and negative 1 multiply together to be negative 6. So that's a no-go there. Okay? So factored, this would be x minus 3, x plus 2, and x plus 3. And that, ladies and gentlemen, could be another potential question where we say factor this polynomial. And we just give you the polynomial. Okay? So we could, given the polynomial, we could say, find me all possible zeros. We could say, factor it. But this one said, solve it. So now what we're going to do is we are going to set, excuse me, our factors equal 0. And that then gives us negative 3, negative 2, and positive 3 as our zeros in our true answer. Okay? But we could have, it's kind of like the bus stops from last week Wednesday. Okay? We have 3 different bus stops on this one. Possible zeros, factored, solved. We take out the just divide 1. Okay? Let's try another one. Okay? So here is, and I should also say, we might combine those two. So it says in this one, first it says list all the possible factors. So that's bus stop new bus stop number 1. And then it says find them all. Okay? Alright? You want to do it together? Do it together? Yeah? Or you want to do it or you want to try one by yourself? You make the call, Lincoln. Try it yourself? Yeah. All right. Lincoln said do it yourself. Do it your own self then. I don't want help. All right. So my factors of 18 are 1, 2, 3, 6, 9, and 18. My factors of 1 are 1. So my possible zeros, oops, one too many. Plus and minus 1, plus and minus 2, 3, 6, 9, and 18. Okay? That's the answer to the first question. Okay? Then, did somebody find one that worked? What do you got, Ella?
6.
1? 1 worked, yep. Okay. Now, so you got 1 to work. You got 6 to work?
Yes.
Okay. Did anybody get negative 3 to work? Did negative 3 work? But it works out? Okay. So here is where, do you guys remember the poem, Two Paths Diverged in the Woods? And I took is it Frost? I think it's Robert Frost. It's a famous poem, Two Paths Diverged in the Woods. I took the one less traveled and it made all the difference. Okay? Here is where 3 paths will diverge off of this problem depending on which 0 you found first. Okay? So if you found 1 first, your path is going to be different than if you found 6 first, than if you found -3 first. Okay? 3 different paths, but they're all going to lead you to the same answer. There's just going to be different work in between them. Okay? So if I do 1, because that was the first one that I heard, then I've got 1, -4, -15, and +18. Drop, multiply, add, multiply, add, multiply, add. So that one is truly a 0. So then I can write my function as if 1 is a 0, then x minus 1 is the factor. So then this would be x minus 1 times x squared minus 3x minus 18. And then I look at x squared minus 3x minus 18, and I say to myself, can it be factored? And it can be factored into x minus 6, x plus 3. So that would be a potential stop if we said factor it. But we said find the zeros, so then I'm going to say x minus 1 equals 0, which gets me that x equals 1, that one that we already found. X minus 6 equals 0 gets me x equals 6, which was the 0 that Loki found. X plus 3 equals 0 gets me x equals -3, which was the 0 that Ray found. So the answer then here, the final answer would be -3, 1, and 6. Again, I remind you that this blue trinomial might not always factor. And in that case, quadratic form. Okay? Because you still have to find all of the zeros. Okay? You now truly have enough tools in your toolbox to do all of this week's worksheet. Tomorrow in class, we're just going to do some more of these type ones. We'll probably have one that uses the quadratic formula and all that fun stuff. I'll show you tomorrow, or we'll show you tomorrow, a shortcut to finding the zero, so you're not trying like 78, because potential, like on that first one, when we had 18 potential zeros, okay, or we had 16 potential zeros, the potential is there that you couldn't find one until you got to the 16th try. Okay? So tomorrow I'll show you a shortcut to narrow that down, which then also allows us to go bigger, because if we have that tool to narrow it down, then we can just keep whittling and whittling and whittling.